Okay, so it's question 12, and I'll do it all. A trailer, so part A, we've got a trailer of mass 600 kilograms attached to a car of mass 900 kilograms by means of a light, inextensible tow bar. The car tows the trailer along a horizontal road. The resistances to motion of the car and trailer are 300 newtons and 150 newtons respectively. Given that the acceleration of the car and trailer is 0.4 meters per second, calculate the tractive force exerted by the engine of the car and tension of the horizontal road, light and extensible tow bar. Right, so we're going to assume that we shouldn't really assume anything, but we're going to look at this as though it is a horizontal tow bar. So there it is, horizontal, and at the moment you've got a tension pulling that and resisting that there, both the same T throughout. You've got resistive force here of 150 newtons and a resistive frictional force there of 300 newtons. This one is 900 kilograms and this one is 600 kilograms, and you've got acceleration of both of being 0.4, and you've got a driving force here, D. It says calculate the acceleration of the, given that the acceleration of the car is there, calculate the tractive force exerted by the engine. Now you can either look at it separately or combined. Now if you do it separately, you're going to end up with T and D, and here you're going to end up with T, and it's a bit messy, so I'm just going to do it combined so you can get rid of the both T's and get out to work out what D is. So that's what we're going to do there. So combined, we're going to resolve to the right is positive. I'll extend that across, and we're going to be using net forces equals mass times acceleration. So in the entire system, we've got a driving force is the only positive force. Take away the 300, take away the 150, and that's it. I'm not going to bother putting T's in because they cancel. Is equal to the mass of the whole system, which is going to be 1,500, very rusty, times acceleration, which is 0.4. So rearranging that, we're going to get a tractive force, a driving force of calculator AC. So 1500 times by 0.4, and you end with that. That gives you 450 when you throw it over. So plus 450, and you end up with 1050 newtons. It's already 3 sig figs. That's hunky dory. Right, so the next thing is the tension of the tow bar. So for this one here, I'm going to look at this. You could look at the car, it doesn't matter. Just a bit more going on with the car, it doesn't matter. So I'm going to go for the easier option and look at the trailer. So I'm going to tell the examiner it is trailer I am looking at. Oh, I'm crossing, I always do that. Trailer. And I'm resolving for the trailer to the right is positive, and I'm using net forces is equal to MA. Okay, so looking at the trailer, the only thing that's pulling the trailer is the tension. Resisting it is 150, and that is equal to its mass, which is 600, times its acceleration is 0.4. So therefore tension is, and this time we get it to be 600 times by 0.4 is equal to, and then add it to 150, and we get 390 newtons, and it's already 3 sig figs, so that's good. Right, for part B, it says, let's try and squeeze it in just down here. It says, given that the magnitude of the force in the tow bar must not exceed 1,650 newtons, calculate the greatest possible deceleration. Now, deceleration means you can either be, using the resistance to decelerate, or you could actually put increase that by putting a braking force, let's call it B, and that will be operating in that direction. And if that's the case, then that is going to want to crush into there. So these now become not tension but thrusts. So they're going to be going in that direction and that direction. Okay, so let's rub this out again. So I've got braking force going there. Whoop, there we go, and thrust in there. Okay, going the opposite direction. Okay, otherwise this is in compression when this is braking. So I can either look at this, but I've got two unknowns, or I can look at this, and that's what I'm going to do. I'm going to look at trailer again, but I'm going to set tension to be the maximum. Sorry, tension, thrust to be the maximum it can actually be. I'm going to set it to be 1,650. So again, I'm going to tell for B the trailer, and again I'm going to resolve to the right is positive. We'll extend that, and I'm going to use net forces equals mass times acceleration. Now the net force going in that direction is going to be minus 150. It is going to be minus 1,650, and that is equal to mass times acceleration, which is going to be 600 times acceleration is going to be positive, so it is A. So therefore acceleration is equal to these two added together, which are going to give you minus what's that, 1,718.00, and I'm going to divide it by 600 to give you an acceleration, and it's saying the greatest possible deceleration of the car, and you can see the deceleration is going to be divide, you can see 3, minus 3 meters per second squared. So therefore greatest deceleration will be 3 meters per second squared. Okay, so don't leave it as a minus there. That's what we're expecting there. Okay, does that make sense?